Converse. Contrapositive and converse are certain other statements which can be formed from a given statement with if then. Let us consider the following if then statement. If the physical environment changes, then the biological environment changes. Then the contrapositive of this statement is if the biological environment does not change, then the physical environment does not change. Note that both these statements convey the same meaning. To understand this, let us consider more examples. Write the contrapositive of the following statement. If a number is divisible by 9, then it is divisible by 3. If you are born in India, then you are a citizen of India. If a triangle is equilateral, it is isosceles. Let us see the solution. The contrapositive of these statements are: if a number is not divisible by 3, it is not divisible by 9. If you are not a citizen of India, then you were not born in India. If a rectangle is not isosceles, then it is not equilateral. The above examples show the contrapositive statement. If P, then Q is if not Q, then not P. If P, then Q implies contrapositive, which implies if not Q, then not P. Converse. The converse of a given statement if P, then Q is if Q, then P. For example, the converse of the statement P, if a number is divisible by 10, it is divisible by 5, is Q, if a number is divisible by 5, then it is divisible by 10. Let us take an example. Write the converse of the following statements. If a number n is even, then n square is even. If you do all the exercises in the book, you get an A grade in the class. If two integers a and b are such that a is greater than b, then a minus b is always a positive integer. Let's see the solution. The converse of these statements are: if a number n square is even, then n is even. If you get an A grade in the class, then you have done all the exercises of the book. If two integers a and b are such that a minus b is always a positive integer, then a is greater than b. Let's take another example. For each of the following compound statements, first identify the corresponding component statements, then check whether the statements are true or not. If a triangle ABC is equilateral, then it is isosceles. If A and B are integers, then AB is a rational number. Let's see the solution. In the first part, the component statements are given by P, triangle ABC is equilateral, and Q, triangle ABC is isosceles. Since an equilateral triangle is isosceles, we infer that the given compound statement is true. In the second part, the component statements are given by P, A and B are integers. Q, AB is a rational number. Since the product of two integers is an integer and therefore a rational number, the compound statement is true.